Welcome to this session of a physical topology. In computer networking, the physical topology refers to the physical arrangement of devices and communication links within a network. It describes how computers, printers, servers, and other devices are connected and how data travels between them. When two or more devices are connected through a communication links, they form a network topology. The topology shows the geometric relationship between network devices, often called nodes, and the links that connect them. Understanding network topology is important because it affects network performance, reliability, maintenance, and scalability. There are four basic types of physical topology: the star topology, the mesh topology, the bus topology, and the ring topology. Let us begin with the star topology. In a star topology, every device is connected directly to a central device, which is called hub or switch. The devices do not communicate directly with other devices. Instead, all communication passes through the central controller. One major advantage of star topology is reliability. If one cable or device fails, the rest of the network continues to operate normally. This makes troubleshooting easier and reduces network downtime. However, the central hub or switch becomes a single point of failure. If the central device stops functioning, the entire network can be unavailable. Because of this simplicity and reliability, star topology is important, widely used topology in modern local area networks. Next is the mesh topology. In a mesh topology, every device is connected directly to every other device in the network. This creates multiple communication paths between nodes. Mesh topology provides excellent reliability, security, and fault tolerance. Even if one connection fails, data can be traveled alternative to other paths. This topology is often used in critical environments where uninterrupted communication is essential. However, mesh topology is expensive and complex because it requires a large number of cables and connections. For a network within the end devices, the number of required links is calculated using a same formula. As the number of devices increase, the cost and complexity increase significantly. The third type of topology is the bus topology. In a bus topology, all devices are connected in a single central cable known as the backbone. Data transmitted by one device travels along the backbone and can be received by another device connected to it. Bus topology is simple, inexpensive, and requires less cabling than other topologies. It is easy to install for small networks. However, if the backbone cable fails, communication across all the entire network stops. In addition, identifying faults can be difficult because all devices share the same communication channels. Finally, we have the ring topology. In a ring topology, each device is connected to exactly two neighboring devices forming a closed circular path. Data travel around the ring from one device to another until it reaches to the destination. Some ring networks use signal repeaters to strengthen and regenerate signals as they travel. The ring structure provides orderly communication and reduces collisions. However, if the communication path is interrupted, network performance may be affected. Traditional ring networks may also experience delays because data travel in a single direction around the loop. To summarize, physical topology describes how devices are physically connected in a network. Star topology uses a central hub and offers high reliability. Mesh topology provides maximum fault tolerance but at high cost. Bus topology is simple and economical but depends heavily on a single backbone cable. Ring topology forms a circular path that supports organized communication but may face performance limitations. Understanding these topologies helps network designer select the most appropriate structure based on the performance, cost, reliability, and organizational requirements. Thank you and see you in the next session.